So here would be an example where I might want to use block. So if I can think of some characteristic that's going to affect my outcome, I would want to block for that. So in this particular problem, I think gender is going to affect the results. So I would first want to block by gender. And you'll always want to write this so that the person reading your paper knows exactly what you did. So we'll have male, oops, and female blocks. And then, seriously, I do not know what my problem is. And then I will randomly assign. So I usually do a little circle here and do random assignment. And again, we still have to talk about exactly how we're randomly assigning using some probability model like table of random digits. And we can describe this later. So we will describe how we're going to do it, because these directions need to be lock solid for somebody who's going to follow my experiment. And so then from the men, I'll have 2 experiment groups, and from the females, I'll have 2 experimental groups, because one is going to get a steroid and the other one gets a placebo or just some sort of dummy treatment. And then same thing for the females. And then at the end, I'll want to compare within my blocks. So I guess I would be comparing, I don't know, muscle mass, perhaps. There's lots of things I could compare with steroids. You know, the effects on your liver, or all sorts of things, right? Not all of them good. So whatever it is that I'm comparing, I'm just kind of making this one up, it would have to tell me in the problem. But the whole notion about this blocking is I want to control for variables that I know about. In this case, it was gender. And then hopefully the random assignment takes care of the rest of the issues. So I'm randomizing because I want to control for the variables that I don't know. So ones you don't. So I'm blocking to control for the variables I know about, and I'm randomizing to control for the ones that I don't. So the next piece we want to talk about is simulation. Remember that we can't actually do all experiments. Sometimes they're morally or ethically not feasible. Sometimes just financially it's not feasible. So I have to be able to figure out a way to imitate chance behavior. Ooh, missed the A. And I want to use a model that accurately reflects the experiment. So I have to take into consideration what are the possible probabilities for each outcome of the event. And then I'm going to use those probabilities to actually do a simulation. So as I said, it might be too costly. It could also be too slow to do it because obviously doing these experiments takes time. And so we're going to use a probability model to calculate a theoretical answer. Here's what you need to remember that you've learned in math. The theoretical answer is the answer that you get from doing some sort of math formula. It's all theory, versus the empirical answer is what I get from actually running trials. There is a difference because running the real trials doesn't always get us the same exact result. A classic example, if I were to flip a coin, let's say 20 times, how many times in theory should I get heads? Obvious answer 10. Is it possible for me to flip a coin and get heads 15 times and tails 5? Yes, that would be a result of my actually running the real trials.